Hi, today we are discussing solving systems of equations, everybody, simultaneous equations. Now, for these, we're looking at two or more equations in two or more variables. Now, when we look at these systems of equations, there are several methods to solve them. So we're going to look at three specific methods today. So for these type of equations, you might see something like this, guys. AX plus BY equals to C. Now you will notice there's an X variable and a Y variable. So they're basically linear equations. So some of the methods I am highlighting to solve these simultaneous equations or systems of equations are graphing, substitution, and of course, everybody's favorite, elimination. So I am going to go ahead and get started with the graphing. Now the graphing, guys, I'm keeping it very brief because it's difficult to solve these systems of equations by graphing. First, you need graph paper. Secondly, they need to be precise in order for this to work, okay? But we have to talk about graphing. When it comes to graphing to solve systems of equations, you want to first write each equation, write down each equation. Okay, we don't need that part right there. Each equation in y equals mx plus b form. Now, AKA slope-intercept form. And then, of course, once you have the equation in slope-intercept form, then you want to go ahead and use the following chart. I'm going to give you the chart next, okay? The chart is simply going to help you to determine what type of solutions you're going to have for the system. So essentially, when you are working with systems of equations, there's three different types of solutions you will encounter, all right? And so the chart analyzes the slope, the y-intercept, and then based on the slope and the y-intercept, that will determine the types of graphs we have, the types of graphs, and then of course, the solutions. And then last but not least, we're going to name the system, the name of the system. So first, we're going to start with the one that has different slopes. If the slopes are different, automatically, you can bypass this. You don't even have to worry about it. When you graph your two lines, okay, remember this is a system of equation, two or more equations in two variables. So if you've got a system of equation, then you've got at least two equations. So when you graph these two linear equations, you will end up with two intersecting lines. If the slopes are different, automatically when you graph them, they will intersect. This point of intersection right there will represent the solution to the system. And when we write these solutions, guys, we write them as a coordinate points. Now, because the system has one solution, of course, that point of intersection, x comma y, this type of system, we refer to it as an independent, okay, I have to go to the next part of this, independent, because I'm running out of room, an independent system. So if it's got different slope, the graphs will intersect. That point of intersection is a solution. And so we end up with one solution, and the name we give to the system is independent. Next, if the slopes are the same, then you need to go look at the y-intercept to go see what's going on. Now, if the slopes are the same, but the y-intercepts are different, then this means that you're going to end up with two parallel lines. Here, let me use a different color. So you're going to have two parallel lines. And remember, parallel lines will never intersect, as in they have no points in common. They do not share any points. So if you have two lines that don't share any points, they have no common points. So we say the system has no solution, no solution. Now, this type of system, we refer to it as inconsistent, guys. Inconsistent is the name of the system, inconsistent. Next, if the slopes are the same, the y-intercepts are also the same. Okay, notice everything's the same. Because everything is the same, this means that we're going to have just one line, or the lines are going to overlap. One line is going to be on top of the other one. So meaning they share every single point because the lines are coinciding or overlapping. So overlap, here, let me write this down. Coincide is another term you can use. I forgot to say parallel here, if you want to go ahead and include that. And of course, the first one, they intersect. So this would be many solution because they share an infinite number of points. And so the name we give this one is a dependent system. So basically, guys, these are the three cases for the systems of equations. Either you're going to have one solution, no solution, or many solution, and the graphs are going to be overlapping. So that's the essence of the graphing. I want you to be able to recognize the graphs, and that's about it. Now, this is where you really are going to start solving these systems of linear equations. And so the second method we're looking at is the substitution method. And when we talk about the substitution method, guys, this works well for some systems, not all of it, because of course you guys don't like working with fractions and you want to avoid the fractions. So the first step in using the substitution method is to go ahead and choose an equation, okay? And then isolate one of the variables. In other words, you need to solve for one of the variables. And so either you rewrite that one equation you choose in the form of y equals 2, or perhaps in the form of x equals 2. But whatever you do, you need to solve for one of the variables, guys. That's the main purpose behind substitution. One of the variables must be solved for. If one of the variables is not solved for, then what's the point? Okay, so make sure one of your equations is either in the form of y equals 2 or x equals 2. Now, once you have this step out of the way, step number 2, you are to substitute whatever you end up with. You are to take it and substitute into the other equation. Substitute that into the other equation. And then, guys, now once you substitute, you're going to end up with a one variable equation. So now you want to solve the equation, okay, using the steps from previous work we've done, solve the equation. And then once you solve the equation, guys, you're not done yet, because remember, this is a two variable system. So you still have to go back and find the other variable by substituting. We're going to substitute the answer. All right. So guys, last but not least, remember, this is a solution. And when you write the solution to a system, write the solution in the form of a coordinate point. Write the solution as a coordinate point, as an x comma y, because this represents a point. Now, what I'm going to do is a couple of examples with you guys, and then I will go ahead and move on to the elimination method, okay? So here's a very easy example to get started with. It is x plus y is equal to 10, and then y is equal to 4x. So for this one, you will notice, guys, the second equation already has a variable isolated. So y is solved for, so you don't have to do any additional work to be able to solve for y. So since y is solved for, whatever it's equal to, we're going to go to the first equation, and substitute for y, the 4x. So we're going to replace y with 4x. So the first equation becomes x plus 4x equals to 10. And now you notice you have an equation in one variable. And so you go ahead and solve for it. So you get 5x equals to 10. So x will equal to positive 2. But you're not done yet because this is a 2-variable system, guys. So you have to go back and find the value of the other variable. Since y is already equal to 4 times x, 4 times the value of x, so we're going to go back in and substitute the 2 in for x and find the value of y, and the value of y turns out to be 8. So as a coordinate point, remember you have to write this as a coordinate point, guys. It would be 2, 8. It doesn't hurt to check these, but for the most part, most people don't like checking. It doesn't matter, guys. Check it if you want to, okay? So if you plug in 2 for x into the first equation, 8 for y into the first equation, 2 plus 8 gives you 10, so it checks. If you go to the second equation and you plug in 2 for x, 8 for y, you get 8 is equal to 8, so it works. So there you go, all right? Now, here comes the second example, everybody. Now, for this one right here, I want to do something that's a little bit more challenging. So I am going to do this next one right here. Negative 2x plus y is equal to negative 8. And then x plus 3y is equal to 11. So again, the first thing we need to do is to choose one of the variables, either x or y, to solve for. It doesn't matter which equation, as long as you choose one of the variables to solve for, just go ahead and solve for that variable. Now, how do you know which variable should be the ideal candidate? The ideal candidate to solve for, guys, has to be a variable that has a 1 coefficient. So in the first equation, you have y, and in the second equation, you have x. Now, personally, I like solving for y, so I'm going to go to the first equation and solve for y, as in isolate the y. So I'm going to take negative 2x, move it over, and when I move it over, it becomes a positive 2x minus 8. So this is what y is equal to. So now I'm going to go to the second equation, and I am going to substitute the value of y into the second equation. So here I'm going to get 3 times 2x minus 8 equals to 11. So we multiply the 3, distribute the 3, we get 6x minus 24 equals to 11. You add these two together, so you get 7x minus 24 equals to 11. You add 24 to both sides, everybody. Add 24. So you end up with 7x, this canceling out, equals to 35. Oh, Shazam, we're ending up with a beautiful number, guys. So essentially, you divide both sides by 7. So what do we end up with? X is equal to 5. But we are not done. There's more, guys. Because this is a 2-variable system, we found one variable, the value of one variable. We have to go back and find the value of the other one. So we're going to go back to this equation right here, substitute the value of x, which is 5, and then we want to go ahead and do the work to find the value of y. So we get 2. So the coordinate point for this one is going to be 5, 2. And guys, that's it. Yeah. So there's 2 solid examples of solving using substitution. Now I'm going to move on to everybody's favorite method, and that is the elimination method. And guys, the elimination method is the one that you really want to learn. If you're having a tough time with any other methods, learn the elimination method because it works for every single system of equations. So here's the premise for the elimination method. Okay, here are the steps. You know, I love giving steps. I love steps, okay? So number 1, you want to write each equation. Write each equation in standard form as ax plus by equals to c. That's standard form, guys. Now, number 2, you want to select a variable to eliminate. And it doesn't matter which variable you use to eliminate. By the way, this method is also called the multiplication addition method. All right. It really doesn't matter what you call it. So you want to choose a variable to eliminate. I wrote the wrong thing here. See, let me erase some of that. All right, there we go. Choose a variable to eliminate. Now, once you select which variable you want to eliminate, you want to make sure, ensure this, guys, make the coefficients the same with opposite signs. And in order to accomplish this task right here, you want to, sometimes you may have to multiply one or both equations by a constant. Yeah, you may have to multiply one or both of these equations by a constant in order to make the coefficients the same with opposite signs. So guys, I am going to erase this so I can move on to the next page because I'm not done. So now, once you've done this, you set out to eliminate the equations, the variable. So you want to eliminate the variable, just like you set out to do. You're going to now add and solve. And of course, just like with substitution, once you solve, you have the solution to one of the variables. You want to substitute to find the other variable. Substitute to find the value of the other variable. So guys, here it is. That is the substitution method. I am going to do a couple of examples with you. And of course, I will always do additional examples in class. So here's the first one. Again, I like to start with an easy one just to ease you into it. So here's the first one, guys. I want you to notice with this first equation right here, the y's, guys. Remember, the goal is to make the choose a variable to eliminate, make the coefficients the same with the opposite sign. If you're looking at the y's here, they both have a coefficient of 1, and plus 1 is negative, 1 is positive, so they have opposite signs. So this is already set up for you to be able to eliminate y. So we're going to eliminate the y like we set up to do. Add 3x plus 5x, that's 8x. And then 5x plus 11 gives us 16. And so now it's just a matter of solving this. So you divide both sides by 8. So you get x equals to 2. Now you're not done. Again, guys, you have two variable system. So you need to find the value of the other variable. So I am going to go ahead and grab one of the equations. It doesn't matter which one. I am going to grab the second one, 5x plus y equals to 11. I'm going to substitute 2n for x and then work it out and find the value of y. This gives me 10 plus y is equal to 11. 10 plus what number gives you 11? 10 plus 1. So y is equal to 1. You could have subtracted 10 from both sides. So guys, the solution, if we were to graph these two equations, they would end up intersecting at the coordinate point 2, 1. And that's it. That's all you're doing, guys. That's the whole process of using the elimination method. So as a promise, I am going to do a secondary example. So here comes the second example. And for this one right here, guys, be careful when you're doing these problems, because remember, the whole point is this: we're looking for solution set. And because we're looking for solutions, be on the lookout, because you might end up with a system that has no solution or many solutions. So be careful, okay? So here's the next one, guys. We have to decide which variable we want to eliminate. How do you know which variable to eliminate? What I typically tell my students is this: the variable with the smaller coefficients. So let me write this down. Variable with smallest coefficient. With the smallest coefficient. And so if you're looking at this problem right here, guys, the x's, they have a 6 and a 4 coefficient versus the y's that have a 1 and a 2 coefficient. So obviously 1 and 2 is smaller than 6 and 4. By the way, it really doesn't matter which variable you eliminate. You can choose any variable to eliminate. But for me, I like dealing with smaller numbers when it comes to math so that we don't get confused. I don't get confused, okay? So we want to eliminate the y variable. To eliminate the y variable, we want the coefficients of y to be the same with opposite signs. So since the second one has a -2 coefficient, we want the first one to have a +2 coefficient so we can eliminate it. So in order to do that, we're going to have to multiply the first equation by -2. And so when you multiply by that -2, guys, you're going to multiply every term by the -2. So you're going to take -2 multiplied by 6x. That's going to give you -12x. Then you're going to take the -2 multiplied by -y. That's going to give you +2y. -2 times -5 gives you +10. Now, this cancels out. You add, and you get -8x. And 6 plus 10 gives you 16. And then you want to divide both sides by -8. So x is equal to a -2. And just like that, guys, we have the value of x. So now it's just a matter of finding the value of y. So we're going to go to the side, grab one of the equations. It doesn't matter which one, plug in the values, and solve. So I'm going to grab the second one here, and I am going to substitute the x value, -2, into the equation and find the value of y. So with this one, I get -8 minus 2y is equal to 6. I add 8 to both sides. So I get -2y is equal to 14. And then I want to divide both sides by -2. So I get y is equal to -7. And so on this one right here, guys, we get a coordinate point in the form of -2, -7 as a solution. And guys, I'm telling you, when you're typing these answers into Math Excel, yes, you're going to need parentheses because this is a point. A point is enclosed inside a set of parentheses, all right? So guys, that's about it for now. With solving systems of equations, obviously, I will do some additional examples in class, but we're done for now, guys. Bye.